Hi, welcome to Unit 5, Day 7, Part 2b. This is example 2. So in this example problem, they're asking me to write the balanced equation for the combustion of C2H6. All right, so again, since it's a combustion reaction, I need to start by writing my reactants and products to get an equation, an unbalanced equation. So I'm going to begin with the C2H6. The other reactant is going to be O2 for a combustion reaction. And then my products are going to be CO2 and H2O. All right, the next thing I want to do is I want to get a tally of my number of carbons and hydrogens and oxygens on both sides. So on the reactant side, I have two carbons. I have 6 hydrogens. And I have 2 oxygens. On the product side, I have 1 carbon, 2 hydrogens, and 1, 2, 3 oxygens. Okay, now what I want to do is change the coefficients so I can have the same number of atoms on both sides, keeping in mind I'll balance my oxygens last. So let's focus on the carbons first. Just because that's the first one that I've written there. You can do hydrogen first if you want, it doesn't matter. All right, so I have 2 carbons on this side and I only have 1 carbon on that side. So in order to do that, I'm going to put a coefficient of 2 in front of CO2 on the product side. So that will give me 2 carbons on both sides. Now remember, once I've done that, I've also changed the number of oxygen atoms since CO2 also has oxygen in it. So I need to recalculate that. So right now I have 2 times 2, so I have 4 oxygens from the CO2 plus the 1 from the water. So 4 plus the 1 gives me 5. Now I'm going to go ahead and balance my hydrogens. I have 6 on the reactant side and 2 on the product side. So in order to get there to be 6 on both sides, I need to change the coefficient in front of water, which is currently a 1, to a 3. So I can have 6 hydrogens on both sides, because 3 times 2 will give me 6. All right, so now that I have the same number of hydrogens on both sides, don't forget this molecule, water, also has oxygens in it, so I need to go ahead and check how many oxygens I have now. So now I have 3 from the water plus the 4 from the CO2, so 3 plus the 4 gives me 7. And notice how I'm just recalculating it by multiplying the coefficients in the subscript. Sometimes what people think is, oh, I added 3 here, so I just add a 3 to the 5. That doesn't work because only the coefficients are, you multiply the coefficients and then you add the total for each. So I just recalculate them. Take your time to do that. All right, so now everything is looking good except for my oxygens, which is great because I want to balance that last. So now the last step is to figure out, well, how can I get the oxygens to balance? So I have 7 on the product side and I only have 2 on the reactant side. So if you look at example 1, what we did was we tried to figure out, well, what number can I multiply the 2 by to get me that 7? Now, is there a number that you can multiply 2 by to get 7? Well, there is a number, but it's not a whole number. And remember, our coefficients must be whole numbers. So if I wanted to figure that out, I would say, well, 2 times what will give me 7? That number is 3.5. So that's a 3.5 there. But the problem is we can only have whole numbers. No decimals. But I can go ahead and put that here briefly because what I want to do now is I want to get rid of that 3.5. And the way I'm going to do that is I'm going to multiply 3.5 by the smallest number possible in order for it to be a whole number. And that number or that value is going to be 2. Because remember, 3.5, it also means a half. If you multiply anything that has a 0.5 in it by 2, it becomes a whole number. 3.5 times 2 will give me 7. Now, the coefficient in front of O2 now is 7. But the key thing that I also have to remember is that whatever you do on one side, just like in math, whatever you do on one side, you have to do to the other side. So if I multiply the coefficient in front of O2 by 2, I have to multiply all the coefficients by 2. Okay, so let's go ahead and do that. Right now we have an invisible 1 here, right? So I'm going to multiply that by 2, meaning the coefficient in front of C2H6 will become a 2. That one's a 7. The coefficient in front of CO2 is 2, so I need to go ahead and multiply that by 2 because I've got to do the same thing to all of them. So now that becomes a 4. And then the coefficient in front of water is a 3. I got to multiply that by 2. That becomes a 6. So what's my current balance equation, my new balance equation? So I'm just going to rewrite this, clean it up a bit. So it's going to be 2 C2H6 plus 7 O2 plus 4 CO2 plus 6 H2O. Okay. So sort of recap here. In this problem, when we balanced the oxygen last, we couldn't find a whole number to put as a coefficient in front of O2 to get the oxygens to balance. So what we did was we used the decimal, 3.5, and then we multiply that decimal by the smallest number possible, 2, to get it to be a whole number. So if you have a 0.5, multiply it by 2 to get it to be a whole number. And whatever we did to one of that coefficient, we had to do to all of them. So we had to multiply all of them by 2. All right, that's it for example 2. Next is example 3.